Now let me introduce you aggregate operators. Sometimes you want aggregate operators like average, some, to do some computations, correct? Example, you want to find out average rating of all the sailors. Then we need some, mathematical function. So all these aggregate operators are going to help you. So maximum is used to find the max element in that particular column. Min is for finding minimum element in the particular column, and sum for summing all that column values. Average for doing average of that all the column values, and count is to count the number of tuples on that particular column. So what is distinct? Sometimes you want to find out sum of only distinct values on that column, then we use distinct. So sum and average and count, with that we can use distinct, but we don't require distinct with maximum and minimum, because example, you have a column A. On that, let's say you are applying maximum, the values are like this: 1 2 3. If max is repeated two times, then if you apply max, then our output is 3. If you apply max and distinct values also, then one of the value will be, one of these two threes will be eliminated, still there will be one more 3, then you get same answer. That's why for maximum and minimum you don't require distinct keyword, okay, and distinct is optional. Example, let's say you have a table, okay, the table contains a column A, and your values are, let's say, 1 comma 2 comma 1 comma 2 comma 3. Then this T1 is nothing but a queries, I mean a table. Then if I write this query, what happens? We'll see. Select sum of, so this is syntax, sum of A from table T1, right? You will write this kind of queries. Then what happens is, this is a usage of aggregate operator. We write sum in select class. Most of the times we use aggregate operators in select class. So I am going to teach you having class after some time. In that also, in having class also, we can use aggregate operators. There are two places I can say. One is in after having, second one in select class, okay. So first of, since we don't know what is having class at this moment, let's ignore it. Let's only write aggregate operators in only select class. So never try to write aggregate operators in where class. That is always syntactical error. I will tell you the reason for that. Let's focus on only select class. Select sum of A from T1. What happens is, so first of all, step number 1 will be done. That means table 1 will be taken. On that, see, this column A will be taken. This is column A, and all the values will be summed up. So that means 1 plus 2 plus 1 plus 2 plus 3 will be the output. Then output will be single value. You get a table with this sum as the sum of A as the column, I can say. 1 plus 2 3 4 6 9. Output will be like this. This is the output, right? If I write select here, let me write one more time. Select sum of, we can write distinct also. For that, sum of distinct A from, let's say, T1. If you do it, then only distinct A values will be taken. In this A, distinct values are 1 comma 2 comma 3, then only that values will be summed up. Then you get 6 as the output. That is the difference between writing distinct and not writing. So finally you understand what is maximum. Maximum gives you maximum among all that column values, and minimum gives all the minimum value among all that column values. That's quite obvious. Sum all that values, just now we have seen. Average is for computing the average. That means total number of values divided by the number of tuples you are doing, I mean you are adding. Example here, if I use average, so average of A is nothing but 1 plus 2 plus 1 plus 2 plus 3 by number of values you are adding 5, right? Then it will be divided by 5. Similarly here, if you use sum of distinct A, then what happens is 1 plus only distinct values will be added, and after that average will be done for only for the distinct values. Number of distinct values are 3, then we divide by 3. If I divide by 5, it's not meaningful, correct or not? Adding only 3 values and dividing by 5, that is not a good average, correct? Average should either take all the values and divide by 5, otherwise only take distinct values and divide by number of distinct values. That's why answer here is 1 plus 2 plus 3 by number of distinct tuples you are taking 3. So it will be 6 by 3, which is nothing but 2. 2 is the distinct average. Okay. So simple average is nothing but 1 plus 2 plus 1 plus 2, which is nothing but 3, 4, 6, 9, right? 9 by 5, 1.8. In that way we can understand about average function. It's very easy. Now we'll see count. So count can be applicable with distinct column value, otherwise simple column value. Example, if you apply simple count like this, what happens? We'll see select count of A from, let's say, T1. Then what happens? So on column A, first of all, column A will be taken, number of tuples will be counted, 1, 2, 3, 4, 5. So output will be 5. If I write select count of distinct A here, then what happens? Number of distinct values will be counted. So number of distinct values are 1 here, 2 and 3, correct? So 3 is the answer. So easily we can understand that. So eliminating the duplicates will be time taking generally. If you really want it, you do it. Otherwise, don't simply write distinct. Whenever you write distinct, there is the query execution time will be increased, because that query which is executed by your query compiler, that has to eliminate all the duplicates. It takes a lot of time, computationally expensive. Be careful. So this is all the story about aggregate operators. If you see last one, count star. What is count star is? Count star is nothing but it counts all the tuples in the table. Example, if you write select count star, star means everything from, let's say, table T1, where let's say T1 dot A equal to 1. What happens, we'll see. So I am taking this table T1 and column A is nothing but 1, 2, 1, 2, 3. So how this query will be evaluated, we'll see. Step number 1, step number 2, step number 3, step number 1. Take table number T1 and evaluate where condition. Whenever T1.A equal to 1, select it. T1.A 1, yes, T1.A 1. Then two tuples will be selected. Current output is, temporary output is 1, 1, just for our imagination. So it is not final output. After that, step number 3, count star will be executed. That means count such tuples. So total tuples, how many tuples we have? 1, 2. There are 2 tuples. Then 2 will be the output. So now at this moment you have doubt. Sir, what is the difference between count of A and count star? You don't understand at this moment. After some time you will be learning null values. In the presence of null values, so count of A and count star might give different answers. I will explain that later. At this moment, if there is no null value, then count on a column, otherwise count star, both gives same answer. Count on a column, otherwise count star. What is count star? Count every tuple. So count on A is nothing but count tuples on column A. So there is no difference. If there are 5 tuples, then the tuples on column A also will be same. Correct or not? Example, let's say you have a table like this, 1, 2, 1, 3, 1, 4. Example, this is A, this is B. Count of A gives number of tuples on column A, 3. Count B also gives number of tuples on column B. Now count star is nothing but number of total tuples in the table, 1, 2, 3. All are same. In the presence of null values, what happens? Actually, count, we'll see that later. At this moment I don't want to discuss. So in the presence of null values, they give different answers. We will see that later. Okay, let's try to use aggregate operators and we write some queries. Okay, so let's say question is find sailor names whose rating is highest. I want to find out the sailor names who have highest rating. So some students write these kind of queries. First of all, we'll see what's the problem with this. One blind rule is, in the where class we should not write aggregate operator first of all. That means where max rating is false, I mean wrong. The reason I will tell you. So here actually in where we should write a condition which should be evaluated to true or false. But you have written here where max rating. If and all if max rating, this kind of syntax is allowed also. What is max rating? Maybe some value, correct? So in where condition, if you write where 100, what does it mean? Generally, in where we should write a condition, that condition should be, comparison, correct? Like A dot rating greater than B dot rating, otherwise A dot rating greater than 100. So we know how to write conditions. So this is not the right way of writing the condition. It is like where 100. What's the meaning of where 100? No, right? So where 100 greater than 50, this kind of thing you should write. So that's fine. If and all, if you want to write the correct one, it should be like this, where max dot rating equal to rating. So first of all, this is wrong. Now what's the problem with this one? I will tell you. Select s dot s name from sailors s where max rating equal to rating. This is actually not allowed according to standard. So if you don't know the standard rule, then you will think that this is correct. So how to remember the standard rule is, blindly remember in the where class we cannot write aggregate operator like this. Okay, I will tell you the logic behind the rule. Example, this is a way query will be evaluated, right? Step number 1, then step number 2, then step number 3. When step number 1 is evaluated, sailor table will be taken. Then in step number 2, where condition is evaluated for every tuple, right? Every tuple we take and we execute this one. So in a tuple, particular tuple, example, let's say first tuple, s.sid, let's say 1, his rating is something 10. Okay, he is nothing but Raju. Then rating is 10 for the tuple, but there is no max rating. Like, it is not good thing to take max rating, because we are evaluating for a tuple one, but for particular tuple you can't have max rating. Max rating is just only will exist for a table, not for a tuple. So when you are in where clause, then we are thinking in terms of rows, right? So for a particular row, rating is good, like we'll have a rating value, but for particular tuple, max is not defined. Any aggregate operator generally will not be defined for tuple, it is defined for table. That's why, being in where class, we should not think about taking aggregate operators. That's why this is wrong. So syntactically, first of all, it is wrong. The reason they say that, in where class you have a tuple in your hand, you are evaluating it. For that tuple, max is not defined. So that's why don't write this one. If you don't understand this concept, remember blindly that we can't write aggregate operators in where class. Okay. Then how to write it? Our question is finding sailor names whose rating is highest, correct? I do like this. I use nested query now. So in nested query, first of all, I compute highest rating. Select max rating from sailors. Now I have computed highest rating here. Now what I do is, using outer query, I do like this. Anybody has, I take every sailor, anybody has this property. That means anybody's rating is this rating. Then I print s.sname, you see. Select s.name or sname, of course. Select s.sname from sailors s, where having this property, where s dot rating equal to this one. Let's try to evaluate this query and understand it. Step number 1, take the sailors, everyone. First of all, take the first sailor, who is nothing but 1, rating is 10, and let's say Raju. Okay, now where condition is evaluated for this tuple. S dot rating for the tuple is 10, right? So 10 equal to select max rating from sailors. So now select max rating from sailors gives what? Try to execute this query. Step number 1, take all the sailors, fine, and after that compute ratings. Take ratings, yes, I take ratings 10, 9, 8, 7, in that way. After that, apply max function. Then what happens? Highest rating will be printed. Here output is 10, correct? Now we are at step number 2. In the step number 2, where s dot rating for our particular tuple, s dot rating is 10, is 10 equal to 10? True. Then print s dot name. So whenever your rating matches with the highest rating, here we are computing highest rating, whenever our particular tuple's rating matches with it, then we are printing the name, then Raju will be printed. Example, there is another sailor Rani. Rani's rating is 9. What happens, we'll see. Then we evaluate this query for second tuple also. When you take the second tuple, S dot rating is 9, 9 equal to 10, false, then Rani will not be printed. Finally, we print a person's name whose rating is equal to this max rating. Understand? So that's why this query is the right one. Correct? Some students argue, sir, can we write equal to? I mean, here right side we have a table, right? So yes, right side we have a table and left side you have a value. How can you write equality between a value and a table? Generally we should not do, but here we know that the result of this query is always single valued. Though it is a table, so remember one thing, it is single value table. Yes or no? Yes. The reason, aggregate operator always gives single value. Remember, whenever you write a query on that select class, if there is an aggregate operator, that query prints only single value for sure. So I can say that this query's result is always single valued. The left side also you have single value. Single value equal to single value is meaningful. But what is wrong, I will tell you. Writing like this is wrong. Select something s dot rating anything from sailors s where s dot sid equal to select s dot sid from sailors. Now see this one. Left side we have single value. When you evaluate this query for every tuple, at a time you will have only single value s dot sid, let's say 1 for first tuple. Let's say I am evaluating for first tuple 1 comma Raju, then equal to, here select s dot sid from sailors. It's a big table with a lot of sailors, right? 1 2 3 4. So it is not guaranteed to be single valued. Then the question is like 1 equal to 1 2 3 4. This is mathematically wrong, correct? So we never compare a single value with set. Right side we have a set. So writing 1 equal to set 1 2 3 4 is false, right? That's why this kind of syntax is not allowed in SQL standard. Either whenever you use equal to, there should be aggregate operator here. Otherwise, the best thing, what is your intention to write equal to? You want to say that this one belongs to this set, correct? So the useful operator here is in. We can use in, but don't ever write equal to. Okay, to write equal to, this right side there should be aggregate operator. So this is a story about aggregate operators. Okay, let's revisit the problem of computing the second highest. How to do that? So when we don't have aggregate operators, we struggled a lot, right? We wrote a very big query. So what we do is, now using aggregate operators we can do easily. We'll see how to find out the second highest. What I do is, here first I compute the first highest, select max rating from sailors. Okay, so semantically this query gives you first highest. Now later what we are doing is, we are taking this outer query tuple sailors, take every sailor. If that sailor's rating less than first highest, if any rating is less than first highest, then it will be either second highest, only second highest, third highest, fourth highest. In that way only that ratings will satisfy this condition. Example, some person's rating is highest. Let's say first highest is 10. Currently I am processing a tuple, okay, and that tuple's rating also 10, which is first highest. Then 10 less than 10 will become false, such tuple will be rejected. Example, you are processing a tuple here whose rating is 9, then 9 less than 10, that means anything other than highest rating will be selected by this where condition. So what I want to say is, when I execute this query, every sailor will be processed, but highest ratings will be rejected because where condition will be false for them. Then other tuples will be taken. Example, let's take an example. The ratings are 10 comma 9 comma 8. So we know that we evaluate this query for every sailor. First of all, sailor number 1, his rating let's say 10, then s dot rating 10, 10 less than, already we know that max rating is 10 here. So 10 less than 10 false, this will be rejected. Then next tuple will be taken, then s dot rating is 9, 9 less than 10 true, selected. Then after that 8, 8 less than 10 selected. Then other than first highest, other ratings are taken. Then we are computing. Step number 2 is done. Now step number 1 is done. Step number 2 is done. In the step number 2, first highest is rejected. Then in the remaining tuples we have other than highest, we are computing max of all such ratings. What is max of that ratings? 9, which is nothing but definitely second highest. So this query gives you second highest. But again, the problem is, what if I want to compute third highest? How you compute it? It will be difficult, right? So this query will give you only second highest. Then how to compute third highest, fourth highest? In that way, I want some arbitrary highest, that means kth highest. How to compute it easily? So I'm going to teach you that. Okay, now we'll see how to write kth highest. Before that, try to understand this query so that easily we can understand kth highest. So what I'm doing is, I'm taking every sailor and I'm running this nested query. Okay, example, let's say first sailor is, we know how this query will be evaluated. Take the first sailor, let's say Raju, and Raju's ID, let's say 1. His rating is something around 10. Now our target is Raju's rating is printed or not, we have to check, right? Raju's rating will be printed only if this where condition is evaluated to true. In where condition I wrote 0 equal to subquery. See, since it is we have written aggregate operator in this query, that result is single valued, so it is semantically correct. So finally our target is, we have to evaluate this query and we should see the count of, that means this value of this query. So here this query's value should be 0, then only Raju's rating will be printed. To get 0 here, we'll see first of all what is this count. Let's start. Select count of distinct T dot rating from sailors T. That means here we have some sailors T. Okay, and take every sailor T and run this where condition. So we know the way this query is evaluated. Step number 1, step number 2, step number 3. Target is what? I just want to see when this count will be 0, whether it is 0 or not. So for that we should understand the meaning of the query. Take every sailor from step number 1, apply where condition where T dot rating greater than S dot rating. To get count 0, because we are counting the number of tuples satisfied by where condition, correct or not? You know how query will be evaluated. This where condition will be evaluated. Example, let's say where condition is evaluated 3 times, this T dot rating greater than S dot rating. Example, we have ratings 20, 30, 40, 10 in the sailors. Then when you substitute first T tuple, T dot rating 20, let's say these are all ratings, 20 greater than 10 will become true, then such T dot rating will be taken. What is that? 20. We'll see that count part, distinct part later. So when condition is true, T dot rating was 20, count it, remember it. Then this we substitute 30 here, where 30 greater than what? This S dot rating 10, right? 30 greater than 10, true, then 30 will be taken. Then 40 greater than 10, 40 will be taken. 10 greater than 10 false, then such 10 will not be taken. So finally 3 tuples will be taken, correct? After that, distinct T dot ratings. So all are distinct, correct? No duplicates. After that we are counting that T dot ratings. How many are selected? 3. So here count is 3. So if there are 3 other ratings which are greater than your rating, Raju's rating, then this count will become 3. To get 0 count, what should be the Raju's rating? Raju's rating should be 50 kind of thing, otherwise 40. If Raju's rating is 40, what happens? No one's rating, because it is highest, then only, then whatever the tuple you take at left side, because we are running over all the sailors, no, then no one's rating is greater than 40. See example, 20 greater than 40, false, reject. 30 greater than 40, reject. 40 greater than 40, reject. 10 greater than 40, reject. It will happen only for highest ratings. Then distinct T dot, in the output nothing is taken, right? So output is nothing now, empty table. In the empty table, take distinct values. Yes, nothing, I mean don't do anything, then that is nothing but taking distinct values. Then count such distinct values. How many distinct values we have in the output? In the T dot rating field, nothing, so 0. So 0 tuples. So now count will become 0. So 0 equal to 0, true, when Raju's rating is first highest, correct? So this query prints the ratings which are first highest. But sir, I want kth highest, seventh highest kind of thing, correct? Let's understand this one. If I keep 1 here, what happens? You see, What is this query is giving? It is giving the count of the ratings, distinct ratings, which are greater than your rating, correct, which is substituted by you. Example, Raju's rating is 40. Then when this count will become 1, how many times where condition is true, that is what will be evaluated, right? Example, one time exactly this where condition is evaluated to true. For that you should have a rating called 50. Only one rating should be greater than 40. Example, see this data 50, 40, 30, comma 20. In this scenario, 50 greater than 40 true, 40 greater than 40 false, 30 greater than 40 false, 20 greater than 40 false. Then only one time this where condition will be evaluated to true. Then T dot rating will be only 50, which is satisfied this condition. Then if you count it, then count will be 1. Now tell me, whenever count is 1, that happens only for 40. That means if your rating which you want to print, that rating is just second highest, then only there will be another rating which is greater than you and it gives count 1 and it matches with this one, correct or not? So, but there is a problem. What if you have duplicates? Example, there are two highest, like first highest 50, 50, 40. What is second highest in this data? 50, 50, 40. So here in my assumption is second distinct highest. Okay, actually in mathematics second highest also 50, but I want to compute in DBMS, in especially in my class I want to compute second distinct highest. This 50 comma 50 is first distinct highest. I want to compute the second distinct highest. So second distinct highest is 40. Okay, so if you want to print 40, then what happens, you see, if you write this query, will it work or not, we'll see. Example, if I write 1 equal to this entire story, will it print second highest, we will see. Second distinct highest, that means 40. So what happens, example, let's say you are evaluating query for 40. Okay, then S dot rating 40. I'm directly coming to the point where the output will be printed. Example, that is 40. Now what happens this query if it is executed? 40, first of all 40 will be substituted here. 40 greater than 40, no, false. Then 50 greater than 40, yes. 50 greater than 40, yes. Two times condition will be true, then such ratings will be counted, but distinct ratings will be counted. Then if I don't write distinct here, what can happen is T dot rating, how many T dot ratings will satisfy this where condition? 2. What are they? 50 comma 50. If you count them, then you will be counting 2. But 2 equal to 1, false. But 40 is really second highest, correct? So that's why it is not about this count I want. So what is the property of second highest? Second highest property is his rating is not greater than only one distinct rating, correct or not? So here if I write distinct, that problem will be solved. Example, if I write distinct, though there are two 50s which are greater than 40, but still 40 is first highest because out of them only one distinct rating is greater than 40. That's why if you write distinct, that will eliminate the duplicates. So what happens, we'll see. Distinct T dot ratings, there are two tuples in the result. Distinct, if I apply, one will be gone. Then if I apply count, that will become 1. Then 1 equal to 1, yes. Then we are printing S dot rating, then 40 will be printed. Okay, sir, my doubt is if I write this one, first highest also will be printed. No. Example, if you have 40, 50, 50, what happens, we'll see. When you take this tuple where S dot rating 50, which is first highest, let's substitute. Why that will not be printed, I will tell you. This query will be evaluated for every tuple, no? 40 greater than 50 false, 50 greater than 50 false, 50 greater than 50 false, then count is 0, correct? If you want first highest, then this should be 0, correct? If you want if you want second highest, then this count should be 1, that means this value should be 1. So when you write 1 here, only 40 satisfy this condition, but first highest ratings, which are nothing but 50 comma 50, when you substitute them, this count will become 0, then 1 equal to 0 will become false and that ratings will be rejected. So finally this query is giving now, if I write 1 equal to something, so that something gives second highest. If you want third highest, then you write 2 here. The meaning of this one, the count of the ratings, distinct ratings, which are greater than you are equal to 2. That means there are two ratings which are greater than you. Example, your rating is something 10. There are two distinct ratings like 20 comma 30, only two distinct ratings which are greater than you. Then this count will become 2. At that time your rating will become third highest. So finally, if you write here 2, then this query computes third highest. If you want to find out kth highest, then you write simply here k minus 1. So here k is a variable, I mean it depends on your highest. Example, you want to find out seventh highest, simply here you write 6. That means there are 6 other ratings which are greater than you, then you will be seventh highest. That is the semantical meaning of this query. That's it. So here finally it is k minus 1, where you want to find out kth distinct highest. Whenever you want to compute kth distinct highest, this will be the query. Okay, now let me introduce you group by and having operators. So far we have seen only select, from and where, right? So when you have group by and having, then this will be the order of the classes. First of all we have to write select, after that from, then where, then group by, followed by having. So here I will tell you some optional things. Where is not compulsory. Let me put star mark, that means not compulsory. Group by is not compulsory and having is not compulsory. If and all if you want to write, but order will be like this. So 1, 2, 3, 4, 5. So some students ask me this one. Sir, after group by can I write again where? No. If and all if you want to write where class, it should be before group by. So order is like this. First write select. If and all if you want to write, I mean after that from. If and all if you want to write where class, write it immediately. Then only go for group by. And again it's not compulsory to write group by. We know that because we have written so many queries so far without group by, right? After that later we can write having. What is the purpose of group by class and having class, we will see. I have some data and I want to do some calculations like aggregate operators or anything. Maybe I want to find out highest rating, but not for all the sailors. I want to compute highest rating depends on the groups, that means based on the groups. Example, I want to find out highest rating for every age group, because I realize that there are it is not the good thing to compute highest rating for total sailors, because there are some sailors whose age is greater than 70. For them, if you compute the highest rating, they will not come in the picture, correct? So that's why generally you have to compute these ratings for every different age group, right? Say maybe what is the purpose of computing highest rating? You want to give bonus to them. To give bonus, if you compute highest rating of total sailors and if you give bonus, always the people whose age is greater than 25, I mean between 25 to 30, most probably they get that, because they have high muscle power and they can sail better than anyone. So they always get better rating than these age greater than 70 sailors. That's why what I want to do is I want to compute highest rating for every age group separately. Example, consider this data. There are 4 people, 1, 2, 3, 4, and the sailors age values are like this: 20, 20 and 70, 70. The ratings are, let's say, something around rating 10, rating 9, and rating 6, rating 5. Now see here, old people are having lesser ratings, correct? Now I want to find out the highest rating for every group. Then what I do is I take the group, I mean here group is nothing but group by age, correct? So age 20 people, these two, among them who is highest 10, so I want to print 10. Then next group is age 70 people. For that, what is highest rating? 6. So I want to print like this: 10 comma 6. 10 is the highest rating in 20 age and 6 is the highest rating in 70 age. So this kind of requirement sometimes will happen for us, right? So we want it. Then what to do? Then do group by. Simply write like this: I want to divide the table into groups based on which field. So that's why we have to specify the column name. Example, in this problem I am doing group by dash field age, right? Group by age. After that, later I want to compute. Later, once you write group by age, whenever you compute aggregate functions, automatically they will be computed for every group. So now you write select class like this. Select highest rating, max of rating. When you do this thing, what happens? So your table will be grouped by age, then later highest rating will be computed for every such age group. Okay, we'll see that. Now we'll see one example query so that you can understand it. Example: select average rating from sailors as group by age dot age. If you write this query, what happens? I will show with one example, numerical example. Example: this is your table. Okay, ratings are, let's say, 10 comma 9 comma 10 comma 9 comma 8. There are 5 people, 1 2 3 4 5, and their age values are, let's say, there are 2 people with 20 age, there are 2 people with 30 age, there is one person with age 70. Just imagination. So for this table, what will be this query's output? To understand how this query will be evaluated, always remember this will be step number 1. Whenever there is a group by class, so automatically first from will be evaluated, then step number 2 is group by, then after that select class. Example, you have here select from where group by having, right? If you have all these classes, then first from class, then where class, later group by, later having, after that select will be printed. That means fifth one is select, finally select class. So here we have only from and group by. That's why first we started from 1. This is step number 2, this is step number 3. Okay, now let me blindly execute this query. From sailors, that means take all the sailors, fine. Then group by x dot age we should do. So this is table, this is age field. So we have to separate the table into groups based on age field. Every distinct age value should be a group. See here. So there are two values, two tuples with age 20, right? So this is a group. So 20 is a group. So 30 is a group. In that way, these two tuples will form a group. So this, there is only 170 value, right, in the age field. So that itself will become one group. There are now 3 groups: group 1, group 2, group 3. Group 1 based on age value 20. Group 2 is because of age 30 people. Group 3 is because of age 70. Now what we have to do is, once this grouping is done, then step number 3 will be evaluated. For every group, any group will be taken first, not a issue. So every group will be taken and average will be, this aggregate operator will be computed. So average rating, take the group number 1. What is average rating for this group? So here 10 plus 9 by 2, which is nothing but 19 by 2, then 9.5 will be printed. So in the output for group number 1, 9.5 will be printed. So we are computing only average rating, right? Now after that, so second group, in that rating is again 10 comma 9, correct? So 9.5 will be the average rating. Then after that third group, in that there is only one element, right? Then sum is 8, only one value, and by 1. Number of values divided by total, sum of the values total by number of such values, 8 by 1. So 8 will be average rating. This will be printed. So it is easy to understand that first of all grouping is done, later all that aggregate operators will be performed. If there is no group by, then total table will be taken as group. For total table, average will be computed. But when there is a group by, then for every group individually, this average or any aggregate operator will be performed. Okay. So before going into more details about this group by and having, so there are some blind rules we should follow. I will tell you the logic behind that rules also. The rule number 1 is, in the select class, some aggregate functions are specified. That means when you want to specify some aggregate operators, then other column names cannot be specified. Okay, don't try to specify other column names unless otherwise, except those which are mentioned in group by class. So we'll try to understand this rule number 1 with one example. If you don't understand this rule, so stop the video and have a look at it. After that we'll see this query. Select s.s name comma max rating from sailors s. What's the problem with this query? We'll see. First, we try to understand and execute this query. Step number one, take all the sailors, then start printing them directly. What you have to print? Name and max rating. Example, let's say your data is like this. Sailors are 1, names are ABC. Okay. Then max rating is, let's say 8, 9, 10. In this one 10. So really speaking, if you execute this query, what happens is, according to semantics of this query, what should be printed is s.s name. This is name, right? So name along with the max rating. What is name for the first tuple A, right? A will be printed. Then what is max rating? 10. So output will be A comma 10. Next, take the sailor name. Next sailor name B and max rating 10. C max rating 10. So in that way, all the sailor names and max rating will be printed. So no one requires this kind of thing, right? So why we want to associate every sailor with max rating? But I understand your expectation. So you are expecting this output of this query like this: sailor name corresponding max rating. That means the person who has max rating, that person's name you want to print. For that you wrote this query. But according to semantics of your SQL, you simply specified that I want sailor name. Which sailor name you did not mention. Then all that sailors ABC will be printed along with max rating 10, 10, 10. So in reality, no one has this requirement. That's why according to standards, what they did is, according to SQL standard, no one is required this kind of output. So such queries are banned. So what is that simple rule? How to remember this ban? Simple. When you write sailor names or any column name, don't specify aggregate operator. If you specify aggregate operator, don't mention this one. So these two together won't go correctly. Okay. So that's why when you have aggregate operator, if you write it, it is syntactically wrong because SQL standard says that it is wrong. But there is an exception. If there is a group by class, whatever the column names you mention, that can be written here. For that we'll see the justification. First of all, this is wrong, right? So aggregate operator along with that ordinary columns we should not write. They are not meaningful. Second thing, see this one. Select age comma max rating. Aggregate operator followed by a column name. But I wrote it, but it is correct. Why it is correct? Read this rule. In the select class, when you use aggregate functions, then other column names cannot be specified except those which are mentioned in group by class. If you already mentioned that column name in group by class, we can use it. What is the reason? I will tell you. First, execute this query, you understand there is a meaning for it. Take all the sailors, right? After that, do group by. Example, your sailors are, let's say, 3 sailors, 1 to 3. Their age values are 20, 20. Let's take 30. Let's take one more sailor, 4, whose age is 40, same 30. Okay. Now, group by is done. Now there are two groups, age 20, age 30. Step number 2 is done. Then step number 3, print max rating and s.age. So since group by is done, then every group's age will be printed. That is what the meaning of s.age. Already I told you, correct? So that's why whenever group by is done, now remaining operations are for groups. Now if I print s.age for the first group, is it not a fixed value? 20, correct? Then what is max rating in this group? Max rating, let's say rating fields are like 9, 10 and 15, 16 something. So max rating of this group is 10. What is age for this group? 20. So both are meaningful because average rating is meaningful, and for this group, writing group name is obviously meaningful. That's why whenever you mention group by class on that s.age whatever, that columns we can mention. Other than that, don't try to write s.s name here. That is what I want to say. Then what happens? This will be syntactically wrong because when you have aggregate operator, then other column names cannot be mentioned except those which are mentioned in s.age. If you remove this one, that's okay. We can print s.age. Remember it as a rule. Now the second rule is about having class. In having class, only two things we can do. Generally, what is the purpose of having? If you understand, then only we can understand the related rule. Okay, before going to the rule, first we try to understand what is the purpose of having. Example, you have a table, and according to group by class, when you write group by class, what happens? Then your table will be separated into groups, right? Let's say these are the groups: G1, G2, G3, G4. Maybe this table is sailors, and you are writing group by ratings. Then what happens? Your group is divided, your table is divided into groups. For every different rating level there will be a group. Example, all these are all, let's say this is rating field, rating 5, rating 5, rating 5, 6, 6, 7, 7, in that way, 8, 8, 8, 8, in that way. So these are the different groups we can imagine. Because of this group by rating, you get this kind of groups. Now later you are going to write having after group by. The purpose of having is, for some groups you don't want to do anything. In reality, once you separate the table into groups, you don't want to do calculations for some groups. You want to simply discard them. Example, you don't want a group whose rating is greater than or equal to 7. That means you want to calculate whatever you want to do, only for groups whose ratings are less than or equal to 5. Maybe you are giving punishment, any, this is rating 5 group, this is rating 6 group. So rating 5 or less than that rating people are not good sailors, they are not performing well. So you don't want to give bonus to them, you want to give punishment to them. For that, so punishment is only for this rating 5, not for rating 6, rating 7, rating 8, because they are good groups. So when you are doing giving punishment, then these groups should be eliminated. Don't give punishment to them. Then discard that groups. So let's do it. Otherwise you are giving bonus. How you give bonus? Only for top performers. Like that means, you want to give bonus to every person in the group where rating is 8, rating is 7, but you don't want to give bonus to rating 5 people, rating 6 people. Then we have to discard them, and whatever the bonus calculation you want to calculate, only do for this. For that, having will be helpful. I will tell you how to use having now to discard the groups. Do you understand that the purpose is discarding the groups? But how to write the condition, we will see. Then we'll go to the rule. What are the conditions we can write in having class? Now we'll see this query and we try to understand how to use having. Find average age for every rating level for those groups who have at least 4 members. Now what is our requirement is, for every rating level we have to, do the grouping. After that we have to compute average age for every such rating level. But for only those groups who have at least 4 members. If any group has less than 4 members, we should not do. Example, let's say you have data like this. Since rating level is a group, let me write like this. This is rating field. So rating 1, rating 1. So this is your data. Rating 1, rating 1, rating 2, rating 2, rating 2, rating 3, rating 3. And let's take two more, otherwise 4. So this is your data, ratings and average age, right? So let me take age field. Age values are 10, 20, 30, 10, 20, 30, 40, 50, something 50, 60, 60, 60, 60, otherwise 70. Now what is our requirement? I will tell you. After that we write the query. For every rating level, see, this is rating number 1, this is rating number 2. Of course, we have another rating 3, right? Rating 3. For every rating level, compute average age, but only for groups who have at least 4 members. This group has 1, 2, 3, 4, 5 members, right? Then we have to compute average age for this group, and there are only 3 people here, then don't compute anything here. And here in rating 3, there are more than 4 people. So we have to compute here also. That is what my requirement. Finally, we have to discard this group. For that we use having condition. So what I do is, first of all, what is clear for me is doing groups, correct? Let's do that. Take the sailor table. Yes, I have taken step number 1. Step number 2, do the groups. How to do the groups? What, based on what basis? Rating field. That's why group by rating. Step number 2 done. Once you have pictorial idea, converting that into query is easy. So step number 3 is what? Discard it. So for that, so we use having. Whenever you want to select or discard any group, we write simply condition on having. What is your condition, you tell me? Sir, I want to take only, groups whose count, it's all about count, right? We whose count is more than at least 4 members, that means greater than or equal to 4, correct? So what we do is having count of star, we write count of, otherwise star, otherwise any field name, count star greater than or equal to 4, that's it. When you write it, so whenever this condition is satisfied, only such groups will be taken. Okay, so now how this query will be evaluated, we'll see. Step number 1, table will be taken. Step number 2, group by will be done, that means your rating fields are divided into groups, done. Then having condition will be applied for every group. Remember, once group by is done, then after that when you write having condition, that having condition will be applied for every group. Let's take group number 1. So in this group number 1, count star. Sir, I have a doubt. What is that, sir? Should I count star counts all the tuples or only the tuples in the group? That is what important thing. So whenever you write a group by class, after that all the remaining operations whatever you are going to perform, they all will be applied only for groups. That's why though you write count star in having, so that count star will count only number of tuples in the particular group, because having is evaluated for every group. Remember it. So that's why let me evaluate having condition for every group. Group number 1. Then count star is applicable for only this group. Then 1, 2, 3, 4, 5. There are 5 tuples. 5. 5 greater than or equal to 4. True. Then this group will be taken, selected. Then second group will be taken. The count is 3. 3 greater than or equal to 4, condition will become false. Then this group will be rejected. Then this group, so let's say this age is 60. Number of tuples here are 5, right? Then count star is 5. 5 greater than or equal to 4. True. Then this group also will be taken. Now only 2 groups are taken. It is easy to understand. Then step number 3 is done. So having finally discarded one group, correct? Now we'll go to the step number 4. In the step number 4, you tell me what to write so that I should compute average age for every group. Simply write average of age. Already I told you, whenever you write average function in select class, if already there is a group by, then that average age will be computed for every group. That's why, so for each and every group which is selected by you in having class, for that only average age will be computed. Then, so this is perfect. So average age here, example 10 plus 20, 30, 60, 70, 90, 90 by something 5 will be computed like this. Here 1, 2, 3, 4, 5. So 60, 60, 120, 180, 240, 310. 310 by 5 will be done. Whatever, doesn't matter. Finally average age will be computed. Now here my question, in having, can I write anything? No, you can't write everything. Example, you can't write having s dot s name equal to Raju. I will tell you the reason. That is rule number 2. In having class, we can use only aggregate operators and only those column names which are mentioned in group by class. If anything is mentioned in group by class, example here rating, only rating field you can specify, but other column names you can't mention like this. Why, I will tell you. Example, let's evaluate this query. What happens, we'll see. First of all, your table will be grouped like this, right? There will be groups. Group by what? Rating. So rating 1, rating 2, rating 3, like this. After that, what you are doing here is, we are selecting groups where having condition is satisfied. So you want to say that I want a group where that group has name Raju. In a group, example rating number 1, in that there are some tuples with Raju name, there might be some tuples with Rani name. Now based on this name Raju, can we select or discard a group? No. Correct? To select or discard a group, that should be group property. Correct? So simply I can say that when you say I want groups where you want groups, right? Which group? Whose group name is Raju? That means in which group sailor name is Raju. So sailor name Raju is not a unique property. What can happen is, example, this is a group. Rating 1, rating 1, rating 1, rating 1. And names are like this. Raju, A, B, C, D. Now, the question is about selecting or rejecting this group. Either I take it, otherwise I reject. But for that, I should not say that I want a group where name is Raju. So based on the Raju name, I can't do that activity. What is that? Selecting the group or rejecting the group. I can select or reject the tuple, not a group. For that, so all this entire group should have same name like Raju, Raju, Raju. Then you are right. Example, imagine, let's say your group has all the sailor names Raju. Then having sailor name Raju means then one particular group, entire group can be taken. Correct or not? But that is not the general case. So that's why to understand this concept, you remember from now onwards, this is not a group property. Based on this condition, I can't select a group or reject a group. That's why don't ever write this kind of conditions. So easily we can remember it like this. This is a sailor name field which is not mentioned in group by. When in group by, if sailor name is not mentioned, don't write it. But sir, why we can write aggregate operators? We'll see. Example, you can write count of something age. Though age is not a column in group by, still we can write it. I will tell you the reason. Count gives what? Count of the group, right? Example, let's say there are some groups. So when you apply count of age, that is a value, like example, count of a particular age in a group. So example, this is group number 1, ratings are 1 comma 1 comma 1, age values are 20, 30, 40. So you tell me, what is count of age for this group? 3. It is a group property. So this is a single value for all the group. But whereas Raju is not a group property and it is not same for every tuple. But here for this entire group, count is a unique property. Like I can say that this group has a count 3, group has count 4, but I can't say this group has name Raju. Correct? Because groups are done by rating field. That's why blindly remember, any aggregate operator we can mention, not a problem. But don't mention without aggregate operator like this. Age, of course we can mention, but that age should be one of the field which is mentioned in group by. Example, if I write age here, if that is the syntax of your query, then that's okay. Because age you mentioned in group by, such age we can use in having class. Okay. The reason is, so because your table is divided into groups by age field. Example, age 20, correct? Age 30, age 40. Okay, let's remove rating for simplicity. Of course, you can have rating also. When I write group by age, then group age 20, age 30, age 40, then maybe you are writing a condition like this, having age equal to 30. Then you are taking a group whose age is 30. Then see, this entire group will be selected. So yes, that is a group condition. From now onwards, you remember blindly two things. Whenever in the having class you write a column name, that should be mentioned in group by. Second thing, any aggregate operator we can write. That's it. Let's see this problem and we try to write the query for this. Especially, this query is an example of group by. Compute average age for the sailors for every rating level. See, he said for every rating level we have to compute average age. That means, so here groups are nothing but based on rating level. Rating is the field. For those people who have age greater than 18, if any person's age less than or equal to 18, we should not consider them. Because for those people who have age greater than 18, then what I do is, I first of all discard them. Then later I do the group by. So what I do is, I know that I require select class compulsory to project the average age. So from dash table, sailors table. So this is clear, sailors S. Now we have to do group by. Before that, I don't want people whose age greater than 18, correct? Whose age less than 18. That's why you write condition first like this. So where age greater than 18, only such people I take. Then only those people I do groups. So for that now I use group by. Sir, why are you doing where first? Why don't you write group by first? If I write group by, then I can't write where class later, correct? That's why order is like this. So group by which field? Rating level. So rating. After that, do you want to discard any group? No. Every group, for that we have to compute average age according to the problem. So having is not required. Then simply compute average of age. That's it. Automatically our requirement will be satisfied. Understand? Now we'll see one more query. So maybe which is little bit different than this one. Okay. Now we'll see one more query. Find the average age of sailors. So we can compute who are of voting age. What is voting age here? At least 18 years old. Yes, we can compute them. Only for them we have to compute average age. So far it is clear. I want to compute average age of sailors who are of voting age, but for each rating level. That means we have to do for every different rating level. Example, this is the data. Then we have to do average age for rating 1 separately, rating 2 separately, rating 3 there is only one person separately, rating 4 separately. So that is what the meaning so far. But we have to do all these things for groups that has at least two sailors. If any group doesn't have two sailors, we should not do. Example, tell me one group here there is which doesn't have two sailors, this one. So this group should be discarded. Sir, that also we can do. How you do it? Simply write having any group having count star greater than 1, correct? But we have to find out average age for only voting age people. That means at least 18 years old people. Then what about others? I should discard. Sir, I do that using where class. Let's try to do that. Finally, first I will tell you the output. Output is like this. So this group should be discarded. For other groups, we have to compute average age. Only for age greater than 18 people are equal to 18. Example here, 20 age, 30 age, 40 age. Let's for simplicity assume that here this age, this person's age is 15. Then we have to do average age only for these two people. That means we have to discard him. Okay. So discard him. This tuple should be discarded. Then 20 plus 30, 50. 50's average is 25 because there are two people. So yes, for level number 1 or rating number 1, I computed average age. Go to the second group. So everyone is having age greater than or equal to 18. Then average age is what? 50 plus 60 by 2, which is nothing but 55. Perfect. For this group we should not do because it has only one member. We have to compute that all these things for only for groups which have at least two sailors. So this group is discarded completely. Now take this group. Example, in this group there is one person whose age is 12. Now the question, should I compute average age or not? First of all, let me ask. This question says that we have to compute average age for the people who are having voting age, but for each rating level that has at least two sailors. So this group has at least two sailors. Some students argue that, sir, after discarding him, why are you discarding him? We have to discard him only for calculation purpose. But if someone asks how many people are there in this group, then there are two. At that time we should not discard because this group has at least two members. It is asking about at least two sailors. Yes, this group has at least two sailors. So I'm just explaining the requirement of this query. So this group also, for this group also we should calculate average age, but only for voting age people. So while doing the calculations, we should do average age only for this person. Don't do for him. Why? Because his age is not greater than or equal to 18. Because see here, find the average age of sailors who are of voting age. He is not of voting age. That's why 65. Sir, but at least two sailors. Yes, this group has at least two sailors. That is what I want to say. So this is final our requirement. But how you do is a question. Then some students think that we can do it easily. How they do is they follow the pictorial representation like this. So finally, end of the day, these people who are having age less than 18 are no use, right? Then we have to discard them. So only in where class we can discard them. So that's why they write where class first. Let's see whether it works or not. Select from sailors. Okay, where they simply discard first s dot age less than 18 people. Further they write condition like this. Select only people whose age greater than or equal to 18. Perfect. So they take only now. Let me blindly show the output by them. This query's output we will see so far. Sailor is taken, then s dot age greater than or equal to 18 people will be taken. This person, and he will be rejected. This person, then this tuple will be rejected. So yes, we want that this tuple and this tuple. later. So this will be discarded, right? So this person will be discarded. Fine. After that they write group by. Yes, we have to do the group by. So group by, what is the field? Rating. Perfect. So then later these arrows are nothing but which are selected by where class. So this and this and this one, right? Later if you write having condition, what happens we'll see. Having count star. Which groups you want? A group whose count is greater than at least 2 sailors, right? Count greater than 1 or greater than or equal to 2. Anything is correct. So greater than or equal to 2. The mistake with this one is, after filtering that people, because of this where condition, this tuple actually deleted. Now after that if you do group by, so this tuple is also deleted because of where condition. Fine, not a problem because we don't want it. But now later you are applying having condition. Step number 1, step number 2, step number 1, this is step number 2, this is step number 3. Then step number 4. When you come to step number 4, count star, if you see, count star of every group. What is the count star of this group? 2, not 3, because this tuple is already discarded. Yes, perfect. And this count star of this group is 2. Perfect. Both are satisfying the condition. But see this group, I am talking specially about rating 4. What is count star? 1. Sir, no sir, it is 2. Some students argue. Then I ask, how it is 2? Because it had two tuples. Yes, it had two tuples, but because of your where condition, one tuple is gone. Then later you are computing this having. Then this having is applied for the resultant table. In the resultant table, no such tuple whose age was 12. Then if you apply count, then this group has only count 1. Then you will discard him. But according to the requirement, this group's average is to be computed, because this group had 2 people. Correct? That's why the problem is, while applying having condition, you want to count old count. That means old group count. But we want to do average age only for that we have to remove this one. If you keep where class, then what happens? This count will be wrong. So we remove where. But if you remove where, then you will be computing average age, let's say, for everyone, for age less than 18 people also. So again, in that sense it is wrong. So that's why what to do then. So here we have to go for nested query. Here I am teaching now nested query with having class. What you do is write where class, no problem. Where, because I don't want any person whose age less than 18. That's why s dot age greater than or equal to 18. The only problem is having count. The count is wrong count. How to get correct count? Then we have to take the old table back. In this computation, in the resultant computation, you don't have correct result, correct? So that's why we go for nestedness. What I do is I write like this, try to understand it. Having 1, so less than, sorry, greater than, otherwise you can keep 2 also. 2 less than or equal to, select count of star from sailors T, where T dot rating equal to S dot rating. Try to understand this query, what happens we'll see. We are counting the number of tuples from the sailor table whose rating equal to S dot rating. What is this S dot rating? This is correlated nested query. That S dot rating is coming from this one. So let's try to understand for one group. Okay, let's take some data here. Now we'll see why this query works. So this is a, let's say, table. Our requirement is what? We have to find out average age for only age greater than or equal to 18 people, and for every rating level who have at least 2 sailors. Yes, see, this group has 2 sailors, we have to compute. This group has 2 sailors, we have to compute. This group has 2 sailors, we have to compute. That means for every group we have to compute. What we have to compute? Average age. Let me do that. Output is like this, average age. Okay, but only for age greater than or equal to 18 people. So this is the only person, right? Age greater than or equal to 18. Then what is the average age? 18. Now here there are 4 people, but age greater than or equal to 18 people are 19 and 20 and 21. Their average is 19 plus 20 plus 21 by 3. That is what the output. So here both are having age greater than or equal to 18. So 25 plus 30 by 2. This is what output. Why this query gives that output, we'll see. So first step is take the sailors. Okay, taken where h dot age greater than or equal to 18. So only people whose age greater than or equal to 18 will be selected. Let me remove the remaining people. S dot age greater than or equal to 18 will be selected. Remaining person means this person will be removed. I don't want. However, we are not calculating him, right? So this will be removed. Then that's it. So these are all the things because of second line, right? So where condition. So tuples whose age less than 18 are rejected. Now group by rating. Already this is group number 1, rating number 1. This is rating number 2, right? This is rating number 3. Yes, already grouping is done. Now having 2 less than or equal to nested query. Whenever you write a nested query, so how this query will be evaluated is for every group, because having is related to groups. So when you write having condition on that, if you write nested query, this nested query will be evaluated for every group. So let's take the first group. In that first group, so this is correlated nested query, right? Then this question mark is nothing but the first group's s dot rating. What is the first group's s dot rating? 1, right? 1 will be substituted here. Then you try to understand this query. If I write s dot rating 1, select count star from new table T. See, this new table is having the old information. That is a trick. In this table, whenever T dot rating equal to C, select count star from sailors T where T dot rating equal to 1. How many people are having T dot rating 1? This is T dot rating 1, T dot rating 1, 2 people. That is giving, group number 1's count, correct? How many people are having rating 1 means what? These are all number of people in the group 1. Indirectly we are computing the number of people in the group 1, 2, right? That count star 2. So that means since there are 2 people, then we have to do calculation for this one. So 2 less than or equal to condition will become true. Then having condition will be evaluated to true. Then step number 5 is what? Select average age for such group. So now some students argue that, sir, if we compute average age, then do we do average age here? No. This average age is referred from sailor S. So because we are in this query sailors means this one, and that already where condition is evaluated, because of that age less than 18 people are gone. Then in the result average age we have to compute. What is the average age for this group now? 18. Perfect. Then we come to again line number 4, because we have to evaluate this query for every group. Already I told you. So in having condition now, second group's variable will be substituted. That means now I am executing this query. Query evaluation is not done. How this query will be evaluated? After step number 3, for every group having will be evaluated. So second group. What is second group? This one, group 2. Rating is 2. Remember. Now s dot rating value will be substituted as 2. Then this query again will be recomputed. Select count star from sailors T where T dot rating equal to 2. How many people are having T dot rating 2? 4 people. Then count star, if you do, then count will give what? 4. So now 2 less than or equal to 4. Perfectly right. Correct. So again this group, that means condition will become true. Then for which group? This group. Then average age will be computed. So here average age only for 19 and 20 and 21, because we are computing average age for sailor table, which is already grouped by. So 19 plus 20 plus 21 by 3 will be done. Perfect. That is what we want. Next time in the same way for third group also same thing will be evaluated. So this is a nested query where having clause is involved. Okay. So this is a way we can understand about group by clause and having clause and this kind of difficult queries. Okay.